Back to Jackson Square. Today we're going to be solving one-step inequalities, which goes along with TEK 6.10a that says I can model and solve one variable, one-step equations, and inequalities that represent problems. So let's jump right in. Remember, I told you solving a one-step inequality or two-step is just like solving an equation. We are going to use our prior knowledge of solving equations to help us be successful with inequalities. So just like equations, we use opposite operations to get the variable all by itself. And hopefully you know that opposite means inverse. Remember, we're using the inverse operation, thinking about what the inverse property says. To get it by itself, hopefully you know by itself means we want to isolate. Okay? So all stuff that we know, we want to use the inverse operations and we want to isolate the variable. So they just said pairs of opposite operations, multiplication and division go together, they're a pair. And then we know that addition and subtraction go together, they're a pair. Instead of getting just one answer, we get a whole range of answers that work. So remember, we talked about that. An equation has one answer, whereas in an inequality, you have a whole solution set or set of answers or a range of answers, okay, for an inequality. There are some things that are important to know. Reversing inequalities. There's going to be a time when we have to reverse inequalities, okay? Anytime you multiply or divide both sides by a negative number, okay? That means the inequality symbol must be reversed. It must be flipped around. So this is very, very important for us to know and remember. Anytime we multiply or divide, this is only when we multiply and divide, we're going to take that inequality symbol and we're going to flip it around, okay? And that's significant because if you don't, your answer won't make sense, okay? Your graph won't make sense. It's very important that we remember to do that. So we're going to do some basic ones, and then we're going to look at some of the ones where we're flipping. But again, if n plus 5 is less than or equal to 16. First, I drew my dotted line. We know that we want to isolate the variable. N wants to be alone. The opposite of adding 5 would be subtracting 5 from both sides. Positive 5 and a negative 5 will cancel out. I'm going to bring down my n. Bring down your inequality symbol. So be careful because you guys are used to bringing down an equal sign. Now it's an inequality symbol. 16 and a negative 5, or 16 minus 5, regular subtraction, that's 11. Okay? N has to be less than or equal to 11. What does that mean? N has to equal 11 or N has to be less than 11. That is what I'm graphing. So because it's less than or equal to, I know I'm going to put a circle on 11 and it's going to be shaded. And numbers that are less than or equal to 11 are going to be to the left. Okay, numbers less than or equal to are to the left. And if you want to use the little trick I showed you, you can draw a little stem and then you're like, oh, there it is. But remember, that only works if the variable is on the left. So the variable has to be on the left to use the trick. And here I had to create my own number lines. And I tell my kids, anytime you have to create your own number lines, this is what you do. You take the number, you put it there, you write one number that's less than it, one number that's greater than it. That's all I need on the number line for you to model it and show me the solution set, okay? So the number, one number less, one number greater, and that's simple, okay? Look at another one. C minus 9 is greater than 14. Again, my dotted line. We know that C wants to be alone. So we're going to do the opposite of subtracting 9, opposite operation, inverse. The inverse of subtracting 9 would be adding 9 to both sides. These will cancel out. They create 0 pairs. Bring down my C. Bring down my inequality symbol. And 14 plus 9 will give me 23. So C has to be greater than 23, okay? I'm going to put a circle on 23. 23 is not a part of my solution set, and numbers greater than 23 are to the right. So I would shade to the right. Anything along this pink line will make that statement true. 24 is greater than 23. 23 and a half is greater than 23. 30, 40, 100, all of those will make that true. So here I'm just going to do a check. So when you check for an inequality, it's different from an equation because you have to take a point, some number along here to make it true. So we're just going to say, what if C equal 24, just for this situation, okay? So C minus 9 has to be greater than 14. We said we're going to replace it with 24. 24 minus 9 has to be greater than 14. 24 minus 9 will give me 15. Is 15 greater than 14? Yes, it is. Okay? So that would make that true. That is a part of the solution set. It will make it true. You can do that with 25, 50, 100, anything that's greater. Okay? If we try to put in 23, that would not make it true. It wouldn't work. Okay? So if you don't believe me, go put in 23, check it yourself, and see if that statement is still true. All right, now we get to the good stuff. So remember we said earlier, if we divide or multiply by a negativo, we're going to have to flip that sign. Flip, 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 okay? So I see that I have a negative 12. I already know in my mind I'm going to have to flip, okay? So first thing we do is that dotted line. We know that G wants to be blown, so we have to get rid of the negative 12. How are we going to get rid of the negative 12? We're going to get rid of the negative 12 by dividing it away. We're going to divide both sides by negative 12. Don't leave that negative. Do not leave it there. Divide both sides by negative 12. Negative 12 divided by negative 12 will give me a G. I'm going to bring down my inequality symbol. Okay, bring it down. 48 divided by negative 12. Again, remember, sleepy mouse. I have a negative and a positive. My answer is going to be negative. So I will have a negative 4. Okay? Well, remember, we divided by a negative. So here, this is where I'm going to, I physically write the word reverse. So I'm going to reverse after I've gotten my so-called final answer. I'm going to reverse. So we think about the cha-cha slide. Reverse, 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 reverse. So this symbol is going to flip, reverse to the other way. So this is what I'm going to grab. G is going to have to be greater than negative 4. Reverse, reverse. Why? Because we're dividing by a negative 12. Okay? We're dividing by a negative 12. So 4, I get an open circle there. Numbers that are greater than negative 4 are to the right. Okay? So I'm going to shade to the right. So I'm going to do a check just to see if this is true. What if we said the value of G was negative 2? Okay? Will this still be true? So we're going to use the orange one where we reverse that symbol to check it. We're going to use the original, okay? Problem solved. Negative 12 times negative 2 has to be less than 48. Negative and negative is a positive. 24 is less than 48. Is 24 less than 48? Yeah, it is. Okay, so what if we would have graphed it, if we wouldn't have reversed it and we would have graphed the other way and we would have put a negative 6 in there? Negative 6 times 12 wouldn't have been less than 48. That wouldn't have been true. So it's only true because we remember to reverse our signal, sign, inequality, symbol. We reversed it, so that is true, okay? So again, checking is important to help you see why it works and why it's true or not true. Here we have P divided by 3 is greater than 9. Again, dot that line, dot the line. So here I don't have a negative, so I'm not going to have to reverse the symbol. There is no negative. This is only when you divide by a negative or multiply by a negative. Negativo. There's no negative here, so I'm not going to be reversing anything. So don't go crazy and start reversing stuff everywhere. So here, first thing I'm going to do is pull out that fraction. I know it's 1/3 times p. Okay. So this is a division problem because I see the fraction bar. The opposite of division is multiplication. So I need to multiply both sides by the reciprocal. Okay. The reciprocal of 1/3, which is 3/1. Over here, 3 times 1 is 3. 1 times 3 is 3. 3/3 is 1. So I'm just left with p. Bring down my symbol. Here I can make this a fraction. 9 times 3 will give me 27. So p has to be greater than 27. Put a circle around 27. Things that are greater than 27 are to the right, to the right, to the right. So I'm going to shade to the right. And remember, anything along that line will make that statement true. 29 is greater than 27. 30 is greater than 27. 27 and 3/10 is greater than 27. All of those things will make it true. Okay? So what I want you to do is I want you to go in and I want you to practice. And please remember, if you multiply or divide by a negative, we want to reverse that symbol. Good luck.